Here are solutions to homework set number 2 for Advanced Embedded Systems. This homework set looks at using loops, if statements, and subroutines in Python. So the first problem is using subroutines, find the total resistance of this circuit. So to do that, I'm going to define a subroutine for adding resistors in parallel, a subroutine for adding resistors in series. Now the total resistance is 500 in parallel with 600. It's right here. That in series with 400, in parallel with 100, in series with 300, in series with 200, in parallel with 700. So that'd be the Python code. When I'm done, I get the same answer as homework set 1, 319 ohms, using subroutines. The thing to note about subroutines is they're reusable. I don't need a separate subroutine every time I call it. Once I get the subroutine, I can use it over and over again. Kind of simplifies the calculations. If I have complex numbers, doesn't matter. Python handles complex numbers just fine. So I've got series and parallel, just like before. I'll need to define what is the square root of minus 1, j. Now I do j30 in parallel with 400, in parallel with 300, in parallel with minus j200, in series with 20, in parallel with 100, in series with j10. So here's the Python code using the same subroutines, and the total answer is, same as last week, 60 minus j4.9. Again, Python handles complex numbers just as well. Subroutines make these a lot easier to calculate. Problem 3 looks at a for loop. I have player A taking the sum of 4 10-sided dice, B takes the sum of 8 6-sided dice. So to do that, to get a single die roll, A and B start at 0 points, I count to 4 and generate a random number between 1 and 10. Do that 4 times, I have 4d10. This is 8d6. Oddity about Python, 11 means 10, 7 means 6 in rand range. A little bit different than MATLAB. That's a for loop. If I want to play 5 matches, that's another for loop. I'm going to play 5 matches. If A won the match, gets 1 point. If it tied, if it lost. And when you're done after 5 matches, print the number of wins, ties, and losses. So when I run this code, I have A won once, 0 ties, 4 losses. Your answer is going to vary, but that's what I got this run. That's a for loop. Problem 4. This is a Monte Carlo simulation. Given this game where A rolls 4 10-sided dice, B rolls 8 6-sided dice, who's going to win a match if the match is the best of 5 games? So what I'll do is I'll first play one game. That's right here. Here's one game. Throw that in a match of 5 games. That's a for loop counting to 5. At the end of the match, who won? If A has more wins than losses, A won. If they're equal, it's a tie, otherwise lost. Now repeat that 10,000 times. That's a Monte Carlo simulation. If I run the match, run 10,000 matches, the probability A is going to win is roughly the number of A wins divided by 10,000. So if I did that, A won 533, ties and losses. A's got about a 92% chance of losing, about a 5.3 chance of winning. Monte Carlo. The last problem is, instead of a match being best of 5 games, suppose a match was win by 2. The difference between problem 5 and 4 is right here. Right here. If I make that a for loop plays a fixed number of games, like 5 games. A while loop is an indefinite number of games. Keep on playing until the condition fails. So as long as nobody is up by 2 games, you keep on playing. So again, play a single game. There's one game. Keep on playing until somebody is up by 2. Then I kick out. That's the end of the match. Once the match is over, so there's a match. Once the match is over, see who won the match. Repeat 10,000 times. So this is a for loop. I'm going to play 10,000 matches. A while loop. Keep playing until somebody's up by 2. What's the chance that A wins the match? Well, with Monte Carlo, I repeat 10,000 times, about 5.9% chance of winning the match. Under this format, 94% chance of losing. So that's homework set number 2, for loops, while loops, if statements, and Python.